Hello everyone, good evening. Welcome back to your own YouTube channel Gate Wallah English. I hope everyone is doing great. So tell me before starting that I am fully audible and visible to you all. Then we'll begin. So good evening Sushil. Good evening. So today basically we are going to move ahead and we'll start evapotranspiration, the next topic. Okay. So before moving further, let us have a quick recap of what we have already discussed till now. So in the last class we have basically covered evaporation. Okay, so we have started the chapter abstractions from precipitation, and I told you that these were the losses we discussed. Evaporation in the last class. Today there is time for today we'll discuss basically transpiration, but one thing you have to understand that we will discuss evapotranspiration. We will combine these terms. Evaporation plus transpiration is none other than evapotranspiration, so we have to discuss that. Okay, so we will discuss it one by one, no issue. And after that we'll discuss depression, storage, interception, and at last we will discuss in this chapter infiltration, which is the most important one. We'll see. Okay, so in last class I told you all the factors which affected evaporation. Okay, we discussed how atmospheric pressure, how vapor pressure, humidity is affecting evaporation. I hope you remember that. Then how quality of water is changing the rate of evaporation. What is the effect of wind velocity? What is the effect of surface area? Is your if your water body is shallow and deep, then how it will affect it? Okay, so we have discussed all these things. I hope you remember it. What is the effect of temperature? All these things we have discussed. Okay, so I hope you remember that. Then in the last class we have left till here. Okay, we have discussed all the methods of measurement of evaporation. We discussed what evaporometers are. We discussed what is your empirical equations. Okay, I told you that in empirical equations we have to remember only Mayer formula. Rover's formula is not important. Okay, it's very huge and you cannot remember it, so we are not interested in that. Okay, so I hope till here everything is clear to you. After this we went on to discuss water budget method also. So I told you that out of these three methods, water budget method was the simplest one but least reliable. The answer which water budget method gives you is not, you can say, not practically correct. Okay, mass transfer is the best one, but obviously we don't have to study that. Energy balance and mass transfer method we will not study because that are not so important. Never question can be asked from this topic, so we'll skip it. Okay, so I told you about evaporometers. Okay, evaporometers are very very important. Class A land pan was the US pan, whose pan coefficient was 0.7, which we have to remember. Then Indian standard pan was there, which is modified class A pan. Okay, in this one we have modified some properties, and its pan coefficient is 0.8. So I told you about these three. Class A land pan is made up of GI sheet. It is made up of copper. Colloidal sunken pan is made up of GI sheet again. So I told you that actual lake evaporation, if you want to compute actual lake evaporation, it is none other than Cp, that is pan coefficient into pan evaporation. So this will give you actual lake evaporation. We also solved one question. I also told you that if you compare pan and lake, so obviously you will see that pan gives you more evaporation. Why? Because it is made up of metal. Okay, then class A land pan whose Cp is least gives you the highest evaporation. That's why we have to multiply it by a very small number. Yes or no? I think this thing is very very clear to you. Wait a second. Yes, so we have discussed earlier, then we solved one question. Okay, good evening dear, good evening. Then we solved one question with the help of which the entire method to compute evaporation was very, very clear to you. Then these were some WMO recommendations. Okay, these were some WMO recommendations according to World Meteorological Organization. The number of evaporometers should be 1 out of every 30,000 kilometers square when we are in dry zone, arid zone, humid temperate climates, one station in every 50,000, and for cold regions we should have one station for every 1 lakh kilometer square. Okay, then we discuss Mayer's formula, which is none other than Km EW minus EA 1 plus U9 by 16. So this is important. Mayer's constants value, you have to remember what is EW, what is EA, U9 we have all discussed. How to compute U9, I told you we have 1 by 7 power law, with the help of which we will find lake evaporation in mm per day. Okay, this will give you lake evaporation mm per day. See, this is important. Remember this question. Okay, I hope you have understood it clearly. Okay, great. Perfect. Good evening, Ajay, and all the students who are joining. So I hope till here everything is clear to you. Then at last we discuss about water budget method. I told you that this is the simple method. If you have a lake and in that if you are able to compute all the other components, if you have the value for all the other phases or components, then what will happen? Then we will simply find lake evaporation using this simple water budget equation. Okay, I hope you have understood this. This is very simple. Okay, this is very simple equation. I have already told you this thing. Then we have energy balance method, but we will not discuss that. Okay, it's not important, that's why I will not discuss it. Then we have mass transfer, that is beyond the scope of syllabus only. Okay, so water budget is the only method which you should consider because it's simple and it's within the scope of syllabus right now, so we will discuss this only. Okay, now we will start our today's class. In today's class, this is your abstraction from precipitation part 2. Basically we'll continue further. Firstly we'll discuss, basically in today's class we are going to focus on these topics like what evapotranspiration is, or what is drought, okay, what is aridity index. We are going to focus on these topics one by one, but before moving further, first let me complete the evaporation topic. In this, one small topic is left, which is none other than what are the methods, what are the different methods in order to reduce evaporation. Okay, so we are going to discuss the methods which we have to remember in order to reduce evaporation. See, I told you that evaporation should be minimal. Why? Because we don't want our water to get lost. We want that water which is being evaporated, we should utilize it, yes or no? We should try to utilize it as much as possible, and we should try that this loss is minimized. Okay, we never favor that evaporation is there. Okay, I hope this thing is very clear to you. It's simple. Okay, basic logic is there. I hope this is clear to you. Now the thing is, sir, how to do it? The question is, sir, how we will reduce evaporation? Okay, see, there are many methods, but let me explain it to you with the help of a beautiful example here. See, many methods are there, but first you have to understand how we reduce it. What is the need, why, and where exactly? So if we talk of where to reduce evaporation, firstly, I told you the concept of evaporation. Okay, so you listen very carefully. So, sir, you told us about river valley. Let us assume we have a river valley. This is your river valley. Okay, so river is flowing. Okay, river is flowing here, and you have obstructed the flow of river by constructing a huge dam. Okay, let us say you have constructed a huge dam here. So if you will construct a huge dam here, obviously this flow will get obstructed, and you will see that in the upstream side, huge amount of water will get collected. Okay, huge amount of water will get collected, and this is known as your reservoir. Okay, this is known as reservoir. Understood, sir? So this water is generally stored in your monsoon season when the river is in, you can say, flashy stage or in floody stage, because in that case, sir, discharge of river will be more, flow will be more in monsoon season. Yes or no? It's simple. So in monsoon season, you will say that flow is more. Okay. Now, when this flow is more, sir, I will collect huge amount of water, and when your monsoon season is not there, when your summer season, dry season will come, then we will utilize this water. But the biggest problem is, sir, that in dry season, you need to understand one problem, that in dry season this water will get evaporated, so we will get troubled. Now how to reduce it? See, many methods are there. We'll discuss them one by one. So let me write here. So methods of reducing evaporation. The very first method to reduce your evaporation is, somehow or the other we have to reduce the surface area. Yes or no? Yes or no? Kindly comment yes. Somehow or the other we have to reduce the surface area. The very first method is reduce the surface area. Okay, reduce the surface area. If somehow you are able to reduce the surface area, then obviously your evaporation will get reduced. Second method is, we will use some kind of mechanical covers. We will use some sort of mechanical cover so that the water from the exposed surface is not getting evaporated. Okay, we will use certain mechanical covers. Okay, we have certain mechanical covers, we can use them if we want to reduce the surface area. See, if we talk of mechanical covers, you must have seen somewhere, or you can search it on Google. Okay, that we have small plastic black balls which keeps floating on the surface. Okay, which keeps floating on the surface so that your water is not exposed. Okay, and evaporation will be reduced considerably. So let me draw. See, these are small floating, you can say plastic balls which generally floats on the surface. So because of these floating balls, you will see, because of these floating black balls, you will see that exposed water, surface area has reduced. So what will happen in this case, you will see that evaporation is reduced considerably. Okay, you will see that evaporation has drastically come down because you have covered the entire lake. Okay, you have covered the entire lake, yes or no? So I hope this thing is clear. You must have seen this. You can simply search it on Google and you will simply find it. Okay, so this is an example of your mechanical cover. With the help of some barrier, you will try to cover the entire area. Okay, otherwise, sir, we have some other methods also. We have certain chemical films. Okay, we can use certain chemicals. We can do dosing of certain chemicals with the help of which you will see these chemicals when go in water, it will come to the top and it will form a you can say a temporary kind of film over the surface. Okay, so we can use chemicals. Okay, we can use chemicals. Let me write one point here, that these chemicals forms a thin film. These chemicals forms these chemicals forms a thin film over the surface. These chemicals forms a thin film over the surface, a thin film over the surface. Okay, and you know one more thing, that these are non-toxic also. These chemicals which I am going to tell you are non-toxic and they are not easily affected by any influence. Let us say if bird comes, okay, if birds comes, insects are there, that film will not be easily affected. Okay, so that's why it is when it will go into water, it will be colorless, odorless. That's why we use these chemicals. So when these thin films will form, so obviously it will prevent evaporation. So these chemicals forms a very small, you can say, thin film over the surface, which prevents evaporation. Okay, simple thing. Perfect. So you have to remember the name of these chemicals. Okay, two chemicals are there, you have to remember the name. So these two chemicals are important. The very first one is cetyl alcohol. Everyone kindly comment in the comment box. Everyone comment the name of these chemicals, because only these names are important from this entire slide. Okay, so cetyl alcohol and sterile alcohol. Cetyl alcohol and sterile alcohol are basically used. I also told you why these are used. I also told you why these alcohols are used. Okay, so this is none other than hexadecanol. This is none other than hexadecanol. And see, cetyl alcohol is also known as hexadecanol and sterile alcohol is known as octadecanol. Okay, both are 10 carbon chain alkane based compound. Okay, in which at 8th position OH group is there, in this 6th position OH group is there. Okay, yes, so kindly comment the uh, name of these chemicals. It's important, that's why I'm asking you. Then we'll move ahead and move to evapotranspiration. So is this thing clear? Is this thing clear? Perfect. Sterile alcohol, cetyl alcohol, both of them are important. Okay, you have to remember both of them. Now we'll move to evapotranspiration. Clear? Great. Now we'll move to evapotranspiration. Okay, now the next thing is evapotranspiration. So you can see a beautiful image here. Okay, you can see a beautiful image here. So one thing is important. Listen very carefully now. If you want to understand the concept of evapotranspiration and sir, why you are skipping transpiration and you are going directly jumping to evapotranspiration. Okay, why it is so important? So that we'll discuss in this topic. So listen very carefully. See, just imagine if you have a plot of land. Okay, let us consider a plot of land. Okay, sir, we have a plot of land, and assume there in that field, on that plot, we are growing some crops. Certain crops are grown. So you are growing certain crops, and let us say you have watered or you have irrigated that land. So can you tell me the exact amount of evaporation which is taking from the field and exact amount of transpiration which is taking from the field? See, you need to understand one thing, that if we consider this entire field, Sir, in this field, both of the process were will be taking place simultaneously. Okay. See, if trees are there, grasses are there, crops are there, they will do transpiration. Transpiration, you all know, transpiration is nothing but simply your roots take up moisture from the soil and they discharge it into the atmosphere through leaves. Okay, you all know that in leaves we have very small openings known as stomata, and through this stomata this water is being discharged into the atmosphere, which is carried by the roots. Okay, so this is transpiration. So whenever you have trees, you have grass, you have crops, they will transpire. And whatever uh, you can say, whatever soil mass is there in the adjoining area, you know, we have certain soil mass, we will have certain small let us say some small water bodies there. You need to understand, all the water will not be transpired. If you have, let us say, 100 meter cube of water, you will see that out of this 100 meter cube water, only let us say 40 meter cube is transpired by plants. Remaining 60 meter cube which is present on the soil, remaining 60 meter cube which is present on the soil will be evaporated. Yes or no? So sir, evaporation takes place simultaneously. So it is very difficult for farmers or any of us. Okay, it is very difficult for farmers or any of us to listen very carefully. It is difficult for us to segregate these two quantities. Okay, it is difficult to evaluate or compute evaporation and transpiration separately. This is just not possible. Okay, so what we did, let us consider this plot of land, and let us say after 1 day or 2 day, or let us say after any time duration, the total losses is 100. So we are interested in combined loss. We will not calculate evaporation and transpiration separately. So I hope the concept is clear that in a particular field, since you can say that computation of transpiration and evaporation separately is difficult and it's of no use also. There is no need to find them separately. So we are interested in finding evapotranspiration. If someone asks you like what evapotranspiration is, so you will say that evapotranspiration is nothing but simply evaporation plus transpiration. If you will water a field, if you will irrigate a field, there you will observe that evaporation and transpiration goes hand in hand, and there is no need to segregate them, consider them under a single unit. Yes or no? So is this thing clear? Okay, so we will consider them in a single unit. So whenever crops consume huge amount of water, that term which we use here is consumptive use. Okay, the term which we use is consumptive use. You need to understand one thing, that in this entire field, let us say 100% water we have given. Okay, just try to understand, this is actual data, so this is a actual fact. So let us say we have given 100% of water to this field, then what will happen, you will see, then what will happen, that out of this 100%, 99% of water will go in the form of evapotranspiration. 99% water will go in the form of evapotranspiration. Okay, 99%. Only 1% water will be utilized by your plants, okay, for their metabolic function. Okay, you know metabolism. Okay, you know animal body also have metabolism, plant body also perform certain functions for which they require water. You all know this. So 1% of water only is utilized for metabolic activities. Remaining 99% is going in the form of transpiration and evaporation. Okay, so is this thing clear? So this 1% of water which is used for metabolic activities is very less. Okay, and you can say it is almost negligible, sir. It is almost negligible. So obviously what we are going to do, we are going to neglect it. I will say that the entire water which is being consumed by plant, is this 99%. Okay, evapotranspiration. That's how we call it consumptive use. Okay, we will ignore this 1%. There is no harm in ignoring this 1% because it is very less. Okay, so what I will say, I will use the term consumptive use. Consumptive use simply signifies the total amount of water which is being utilized consumptively for tissue building of your crops. Okay, so consumptive use will indicate here evapotranspiration. Now if someone asks you like what consumptive use is, you will say it is evapotranspiration. And evapotranspiration, see, higher the evapotranspiration or more is the evapotranspiration, you will see the growth of plants or growth of crops will be better. Okay, So consumptive use is indicating evapotranspiration only 99%, remaining 1% we are ignoring. Okay, this is the deep concept, not so important. I hope this is clear to you. Now, see, consumptive use term, if someone asks you like what exactly consumptive use is, simply you will tell that it helps in the growth of plant. Okay, consumptive use of water means that water will help in the growth of plant, simply. Okay, exactly this is 99%, but we are considering it approximately equal to 100% that I have already told you. Yes or no? So I will write one point here. This helps in consumptive use evapotranspiration needs, helps helps in the growth of plant, helps in the growth of plant. Okay, is it clear? And I hope you have understood why we are interested in evapotranspiration. Okay, I hope you have understood this thing. Now we'll discuss two important terms, which is actual evapotranspiration and potential evapotranspiration. Okay, we don't have slide here, so we'll write on this one. Okay, now two terms you have to understand. So you have understood this thing, evaporation and transpiration combined is known as your evapotranspiration, because there is no need to segregate them, and it is also tough for us to segregate them and compute them separately. Now in evapotranspiration you have to understand two definitions. Okay, in evapotranspiration two basic definitions are there. The very first one is potential evapotranspiration. Let me write here the definition of potential evapotranspiration. Potential evapotranspiration. Okay, potential evapotranspiration is abbreviated by PET. Okay, PET means, PET stands for potential evapotranspiration. Now, what is the meaning of potential evapotranspiration? And we have one more term. We have one more term known as actual evapotranspiration. We have one more term which is known as actual evapotranspiration. So let me get the concept straight to you, then we'll compare them. First let me explain, then I will write down the definitions of both of them. So we have PET and we have actual evapotranspiration. ET means evapotranspiration, A stands for actual here. Okay, so that is PET, this is AET. Now you need to understand the difference between the two. PET means potential evapotranspiration means your plant, see, evapotranspiration means water need. Evapotranspiration need means water need of this entire land mass. Okay, so you need to understand that why we are referring evapotranspiration uh, equivalent to consumptive use, because we are considering that this entire piece of land, this entire plot of land is fully covered by the vegetation. Okay, we are considering that this entire plot of land is fully covered by vegetation and only transpiration is taking place here. Okay, all the water is being used. See, we will not use barren land here, or you can say open land in which evaporation will be the bigger part. Okay, we are simply assuming that this land mass is fully covered with water, vegetation. This land mass is fully covered with vegetation, so that whatever water is being consumed is consumed by crops only. Yes or no? Yes or no? Perfect. Ravi Kumar Singh is saying motivation. Okay, don't worry. First, let us complete the topics, then we'll discuss about motivation. No need to worry. Now, you need to understand one thing, that in potential evapotranspiration, in PET, see, you have, listen very carefully. Let us take an example. Let us say we have a crop here. Let us say we have a crop. We have provided sufficient quantity of moisture. Okay, let us say we have provided sufficient quantity of moisture here. Okay, and sun is also shining perfectly. Sun is also shining perfectly. Wind is also blowing at a steady state. So wind is proper, sunshine is there. Okay, optimum moisture is also there. So you will see that in this case the consumptive use or the consumption of water will be very high, and it will be maximum. Okay, this is the maximum amount of water that your plant will consume, that your crop will consume. Okay, crop is, you all know that crops are basically eaten by animal kingdom. Okay, you all know this. So what we are interested here is, sir, potential evapotranspiration means the maximum water supply, or sorry, the maximum water consumption, not supply. We are not supplying anywhere, but you need to understand that potential evapotranspiration is referred to as the maximum water consumption by your plants, but that depends on many factors. When this plant will consume maximum water, when this when the consumption of water will be maximum, sir, only when you have these 3 to 4 conditions. Sir, listen very carefully. The first condition is we should have optimum amount of water here. If water is not there, sir, if water is not there, how could the consumption be maximum? Yes or no? Sir, if water is not maximum, if water is not, you can say, in sufficient quantity, then potential evapotranspiration cannot occur. Let us assume the value of potential evapotranspiration is 10 centimeter. Okay. And sir, this 10 centimeter depth of water will only be consumed when proper moisture, proper availability of water is there. First point. Second point, proper climatic conditions are there. Sun is shining brightly, winds are also blowing properly. So if climatic conditions are also proper, moisture is also there, okay, and you can say plant is in full form in the daytime, okay, obviously. See, one more thing, evapotranspiration is limited to day hours only. Why? Because in day, you all know, sunshine is there, and because of this sun, you need to understand this sun basically, uh, sun drives sun drives water out of this plant, okay. In this you can say phylum and xylem, you will see in all these you can say fibers of your plant or crops, you will see vacuum has been created because of sun. So because of this sun only, you will see that your evapotranspiration is limited to daytime only, okay. So you need to understand one thing, that this maximum water consumption or potential evapotranspiration will only take place when we have sufficient moisture, when we have optimum climate, sun is also shining brightly, winds are also blowing perfectly. So this is the maximum value. Let us assume the maximum value of water, the maximum depth of water which my plant can consume in a single day, let us say it's 10 centimeters. Too much, but we are assuming, okay, no problem. Now, what is actual evapotranspiration and how it is different from PET, how it is different from potential evapotranspiration? Sir, you have already told me that this potential evapotranspiration thing is a upper limit, is the maximum value, okay. Now, actual evapotranspiration means, now let us try to understand the fact that actual conditions can never be, you can say, satisfactory. In actual, sometimes you will see that your plant or crop is not having a drop of water, it's completely dry, okay. Dry condition can also come. So in practice, actually, in actual condition, you will see that in prevailing conditions, in real situations, you will see that evapotranspiration will be quite different. It can never be maximum, okay, because water shortage is there. Let us say we have not supplied the water properly. Let us say sun is not shining brightly. Let us say clouds are there, or you can say night time is there, okay, winds are not blowing. So sir, you are simply saying, okay Ryan, great. Okay, so what I am saying here is that since your actual evapotranspiration depends on real condition, present situation, prevailing conditions, that's why this actual evapotranspiration thing will be less than this potential evapotranspiration. But yes, if in actual the conditions are almost equivalent to this one, then obviously you can say that actual evapotranspiration will be equal to potential evapotranspiration. So what I will say here is that I will write here that actual evapotranspiration can vary, okay. It can be as low as 0, okay. Sometimes when there is no moisture, no, you can say no water is there, no moisture is there in the field, then in that case I will see that actual evapotranspiration will be 0. But when sufficient moisture is there, sufficient sunshine, bright sunshine is there, and windy conditions are there, so in that case our evapotranspiration will be highest, and that will be equal to PET. So actual evapotranspiration, okay, actual consumption of water varies from 0 to a maximum value. It varies between 0 and a maximum value. So I hope this thing is clear. So you need to remember that actual evapotranspiration can vary from 0 to a maximum value. Maximum value is known as PET, and the lowest value is your 0. Actual evapotranspiration varies. I hope this thing is clear to you. Is this thing clear? Now we'll quickly write down the definition of both of them. Great, Rayan, you are watching it in class 10. Then when you will go in BTech, you will see the magic. Okay, perfect. So this is basically from class 9th only. Okay, you must have read the terms evaporation and transpiration separately, but in engineering we have combined it only, nothing else. Now, what is potential evapotranspiration? Let me write the definition. Let me write the definition here. If moisture if moisture is present in sufficient quantity, if sufficient moisture, if sufficient moisture is always available, if sufficient moisture is always available to completely meet the needs of 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 vegetation fully covering the area, completely meet the needs of vegetation fully covering the area, fully covering the area. We have an area in which the land mass is completely covered with vegetation. In that case, all the evapotranspiration, in that case only evapotranspiration will take place. Okay, all the water will basically be consumed by crops only when you have fully covered vegetation covering the area. Then in that case it is known as potential evapotranspiration. And also one more thing you need to understand, this PET thing not only depends on moisture. If you have more moisture, obviously more evapotranspiration will be there, but it depends on climatic condition also. Okay, PET depends on PET depends on climatic condition. If temperature is higher, then I will see that PET is more. Okay, so potential evapotranspiration depends on temperature, depends on sunshine, depends on wind. Okay, so this PET thing, the maximum value of evapotranspiration depends on climate also. Okay, this is important. Yes or no? Perfect. Okay, now we'll discuss actual evapotranspiration. So actual evapotranspiration will be less. Yes or no? So let me write here. Actual evapotranspiration can be less also. So let me write the real evapotranspiration. If you have less moisture, if your soil does not have sufficient moisture, okay, let us say your soil does not have sufficient moisture, in that case what I will see, in that case the real evapotranspiration will be less. The real evapotranspiration which is occurring in prevailing conditions, actual conditions, when water is less, that is actual evapotranspiration. In that case evapotranspiration is known as actual evapotranspiration. So actual evapotranspiration will be always less than PET and the minimum value is your 0. Okay, but yes, when actual evapotranspiration is 0, in that case drought will happen. You will see that all crops are dying. Okay, that is obviously the extreme case. We are not interested in that one. So I hope this thing is clear to you. Now we'll move on to the measurement. Okay, how we measure evapotranspiration now. So measurement of evapotranspiration is basically done with the help of a meter. You can see this meter known as lysimeter. Okay, see, let me tell you all the other meters also. Till now we have covered 3 meters. See, we have discussed evaporation. Okay, so evaporation is measured by atmometer or evaporimeter. The meter which measures evaporation is none other than atmometer or evaporimeter. Okay, understood. Sir, transpiration is measured by? Sir, tell me how transpiration is measured. See, transpiration is measured by phytometer. Remember it? Remember this thing also. Transpiration is measured by, sir, phytometer. Okay. Now the third thing is evapotranspiration, which you have to discuss in this slide. The third parameter is measured by, this third parameter evapotranspiration is measured by lysimeter. Everyone kindly comment the name of this meter because this is asked in your examination. Okay, we have a small you can see cylindrical tank here. You can see this cylindrical tank here. I will explain how this measures exactly evapotranspiration. I will tell you, but tell the name of this meter. Everyone kindly comment. Everyone kindly comment. This is important. Okay, this is very important. So the method, or the, you can say the name of the meter with the help of which we measure actual evapotranspiration is lysimeter. Okay, perfect dear, great. Now sir, this is your lysimeter. Sir, how it measures evapotranspiration? How this lysimeter thing will measure, tell me how it will measure evapotranspiration. So we have to understand the logic behind it. Okay, so what we do basically, see, you can see this, it's a kind of pot. Okay, you must have seen plant pots which are there basically for used for decorative purpose in our homes. Okay, you must have seen such kind of pot. So obviously it's a metallic cylindrical pot here, in which you can see one crop has been placed. Okay, you can see this crop here. So this crop has been placed in a metallic cylindrical pot. Okay sir, this is very clear to us. Now sir, what happens here, what I will do with this, so this setup will be sunk into the ground. Okay, how come sir? So let us imagine we have land mass here, we have land, soil basically. In this soil mass we will you can say excavate a hole, or we will uh, dug some earth, and the place which is left in between, we will sink this cylindrical pot here. Okay, we will sink this cylindrical pot here. Let me draw it with another ink. Okay, so this is your lysimeter. Basically this is your lysimeter. At the bottom you have certain perforations, so that whatever water you will give to this plant, that will come out from the bottom. Okay, now what will happen, see, you need to understand one thing. See, this is soil mass, and on the soil mass you have small crops, you all know. Okay, you have small vegetations on this uh, on this soil mass. Okay, so we have certain kind of vegetations on your soil mass. Now what I will do, in this lysimeter we have a certain crop, and that crop is similar to the adjoining areas, because obviously we are interested in finding the evapotranspiration in that area. We are interested in finding evapotranspiration of that field only, of that soil mass only. Okay, so what I will do here is, I will properly fill this lysimeter or pot with the soil, and in this soil I will grow the same crops. Okay, in this soil I will grow the same kind of crops. Okay, here I will grow the same kind of crops. Okay sir, now what, I will also water it. And I will wait for a single day. See, what we have to do here is, we will water this. And wait for a single day. See, also one more thing. At the bottom we have a collector. Okay, at the bottom we have a collector, because whatever water we give, that gets automatically collected at the bottom. You know this thing. This is not something strange or something new. Okay, so how we'll measure actual evapotranspiration? Tell me that thing. So this is basically done with the help of water budget equation. Okay, so what I will do, see, we will apply water budget equation here. Listen very carefully. This is a collector. Which is present at the bottom to collect the water. Now what I will do here is, that at the bottom if we want to at the bottom water will get collected. If we want to measure actual evapotranspiration, so that will be measured simply. See, this is a kind of loss. So what we have to do, we have to measure the weight of the water initially, and weight of the see, let me tell you. So what I will do here is, I will take the weight of initial soil system setup. Okay, WSI is weight of initial you have set up this entire, you can say, pot, and this soil and this crop mass. Take the weight of this setup initially, and then add some water. Okay, WAD will be denoting here, how much water we have added. This is initial weight of the setup. Let me write here, WSI is initial weight of setup. Let us assume some values. Let us say 100 kg. Okay, 100 kg is also very high value. Let us say 10 kg. Okay, and we have added some water here. So this WAD is added water, so that your crop grows greatly, and whatever evapotranspiration needs are there, that are sufficed. Okay, or that are met basically. Now what will happen after a certain time, after one day, you will see, after one day, see, this is your inflow, this is the initial mass. Now what will happen, some water will get collected here, that is WC. Some water will get collected at the bottom, that is water getting out of the system. Okay, that is WC is what? Water collected in the collector at the bottom. So I will write water collected at bottom, water collected at bottom. So this is WC. What else? What else? Sir, this is WC. And what else? Find the weight of the setup finally. Okay, WSF. WSF is final weight of the setup. Okay, let me write here. This is final weight of the setup. WSF is final weight of setup. So now what will happen here is, listen very carefully. So this is 10 kg, just assume you have added 1 kg of water on day 1. Okay, now you have it, you have come after 24 hours. Okay, you are coming after 1 day exactly. So initially the weight was 11 kg. Initially, after giving it water, the initial setup weight was 1 kg. Now you will see that 0.5 kg water has collected at the bottom. 0.5 kg has of water has come down to the collector thing. Okay, now final weight of the setup is, let us say it is somewhere around 9, or let us say 9.5. Okay, sir, initial weight was 10, but final weight is 9.5. Sir, why? Because this soil was consisting 500 grams of water that has evaporated. So 500 gram of water has gone from here, and remaining 500 gram of water has been evaporated, which you have added. So how much is your actual evapotranspiration? See, there is a difference. This is 11 and this is 10. So where this 1 kg has gone? Where this 1 kg has gone? Obviously this 1 kg has gone in the form of evapotranspiration in one day. Yes or no? Have you understood this thing? Obviously the water which is missing from here has gone out in the form of evapotranspiration. Yes or no? From the leaves of your crops. Okay, so I hope this thing is clear to you. So with the help of simple water budget, equation, we have easily computed your actual evapotranspiration. So this is a field method kind, this is a kind of field method. But yes, lysimeter, one drawback is there. See, one drawback is there, that is for sure. Drawback is that it takes hell lot of time. Okay, we have to keep waiting. Okay, we will wait for this entire process to happen. Okay, and for this entire evapotranspiration thing to happen. So obviously it takes a hell lot of time. So this is a, you can say, disadvantage here. So I will say that it is time taking. This process is time taking. You should remember this. This process is time taking. And one more thing, this process is time taking, and also it is expensive, and it is expensive also. Okay, so this process is time taking and this device is expensive. So this is some characteristics which you should remember. Okay, this is the characteristics of lysimeter. So if someone asks you like what is lysimeter, you will say lysimeter gives you measurement of actual evapotranspiration. So I hope this thing is clear to you. Okay, one doubt is here in the comment box which I can see here is pre of this year not clear. Don't worry dear, keep preparing the very first pre. So is this your first pre or which one? Last year you missed ESE mains by 4 marks. Great. That means you have already covered almost all the concepts. Okay. See, this type of things happen with many students. Okay, so there is no need to get disheartened. Just keep moving forward. Okay, every time your expectations will not be met, but the thing which is in your hand is you have to keep working. Okay, consistently. Okay, you are saying please teach SOM. See, SOM dear will be taken basically by Anirudh sir here. Okay, so that is not my subject, so basically he will be dealing with it. But don't worry, in this entire year you will come across with SOM. Someone or the other will take SOM, don't worry. Okay. Okay, now we'll move on to discuss another method. Okay, now we'll discuss. I hope this entire concept is clear to you. What is lysimeter and what it measures exactly. Okay, now we'll discuss Penman's equation. Okay, how we measure PET. See, actual evapotranspiration is measured by lysimeter only. Now we'll go for measurement of potential evapotranspiration. So this heading is wrong. Let me correct it. We have to write here measurement of PET. Okay, two equations are there for measurement of PET. You can see it on the board. Okay, so PET. Okay, so we have to measure two things. Sorry, PET is measured by basically two methods. The first method is your Penman's equation. You can see Penman's equation written here. Okay, so basically we have two methods for measurement of PET. The very first method is Penman's equation. Okay, so we'll discuss this equation. I hope this entire lysimeter concept is clear to you. Yes, perfect. Now we'll discuss Penman's equation. So Penman was a scientist who came up with the equation. Okay, and in that equation he gave certain, you can say, constants and some terms, with the help of which, if we'll have those values, we'll put them in the equation and we'll directly evaluate what, and we will directly evaluate your potential evapotranspiration. So some important points. Sir, ISRO written is easy. Yes, it's easy if you practice well, and at your level, I guess, since you have just missed mains by 4 marks, as you are saying, so in that case it will be very, very easy for you. But yes, dedicated preparation, what to do, what not to do, that has to be there. Okay, so if you are guided, you can easily crack it. Okay, now we'll discuss Penman's equation. So Penman's equation is based on, let me write the very first point. It is based on combination of it is based on combination of energy balance, and it is based on combination of, let me write this with another ink, it's an important point, it has been asked in ESC prelims 1. It is based on combination of energy balance, it is based on combination of energy balance method and mass transfer method. So I already told you that this energy balance and mass transfer approaches are better than water budget method. Yes or no? That's why he has combined it, energy balance method and mass transfer method, or approach, I can say. So it is based on combination of energy balance and mass transfer. But how, that that there is no need to understand. Simply try to remember the equation and this line. Okay, equation is also not important because never ever this equation has been asked, but still one question has been there, so we'll discuss equation. Okay, so PET is given by AHN plus EA gamma upon A plus gamma. EA gamma plus A plus gamma. This is your potential evapotranspiration. This is your potential evapotranspiration as given by Penman. Okay, he's a scientist. So potential evapotranspiration is coming in which unit here? It is coming in mm per day. Okay, when you will put the values of these parameters here, if you will put the values of these parameters here, you will get potential evapotranspiration in mm per day. Okay, now what is the meaning of all these terms? We will discuss them one by one. So the very first is HN. HN is what? HN is simply your net radiation. Okay, net heat. See, what is net radiation? Let me tell you this thing. What is HN? See, simply you have to understand. Let us say this is the surface of Earth on which many crops are growing, or you can say it is a field in which is fully covered by fully covered by your crops. Okay, let us say this is your field. Now you need to understand from sun some heat will be incoming. Okay, so let us say this is the heat which is coming towards the earth surface. Obviously what will happen, some heat will get reflected, some heat will get reflected. That heat which is getting reflected is R times Hc. R is nothing but some fraction. R is reflection coefficient. Okay, you need to understand. Let us say R is 40% or 0.4, which means whatever heat is coming out of that 40% heat will reflect, only 60% will remain. Yes or no? Only 60% will remain. Yes or no? So R is what? Coefficient of reflection coefficient. So out of this total energy, you can say some fraction has reflected, some fraction will also go away in the form of back radiation, so if I will ask you how much is the net heat energy, how much is the net heat energy which has stored here or which is remaining, then what you will answer? I will answer, sir, total energy which is incoming, total incoming solar radiation is Hc, then this much amount of heat energy is reflected and this much amount of heat energy has gone away in the form of back radiation. So net radiation is H1 minus R minus HB. Okay, so this is Hn. Hn means net radiation or net solar radiation, which is, you can say, is now remaining. Okay, remaining solar radiation it is. I hope this thing is clear to you. So Hn is net solar incoming radiation. Now what is A? A for, what is A? A is slope of saturation vapor pressure, which is EW. It is denoted by EW. I hope you all remember what is saturation vapor pressure. You should understand it. When your atmosphere is fully saturated with vapors, at that time whatever pressure is being applied by those vapors is known as saturation vapor pressure. It is the maximum moisture holding capacity of your atmosphere. Okay, so slope of saturation vapor pressure versus temperature, slope of saturation vapor pressure versus temperature at mean air temperature, See, what is the meaning of this? See, I told you the graph. Okay, I showed you the graph of slope. See, I told you the graph of saturation pressure versus temperature. Okay, I told you that when uh, temperature increases, saturation vapor pressure or the moisture holding capacity of atmosphere also increases. Okay, so let us say the mean air temperature is 30 degrees Celsius. So at 30 degrees Celsius, I will take the slope of this graph. Okay, at 30 degrees Celsius, I will take the slope of this graph, which is A. A for slope. A is the slope of saturation vapor pressure versus temperature curve at that point. Okay, perfect, clear. So this is A. Now, so this is net radiation, this is slope of saturation vapor pressure. Now we'll move to EA. What is EA? What is EA? EA is parameter including, EA is a constant, or you can say a parameter. It is a kind of parameter which is including wind velocity, which is including wind velocity, and saturation deficit, Okay, you all should understand this fact. Wind velocity and saturation deficit is also influencing evapotranspiration. If wind velocity is higher, then you need to understand, if wind velocity is higher, then obviously your evapotranspiration will be more. If saturation deficit is more, then also evapotranspiration is going to be higher. Okay, so EA is parameter which is including wind velocity and saturation deficit. Now at last we have gamma, which is psychrometric constant. This is psychrometric constant. Okay, gamma is psychrometric constant. So HNA gamma can be put in this equation and simply you can obtain PET. So I hope this equation is clear to you. Not so important, but yes, you should remember the very first point. Okay, so I hope till here everything is clear. Now the next method we will discuss, this was the first one. This was the first method with the help of which you can remember, with the help of which you can find PET. In examination, like what kind of questions will be framed from here? In examination, they will ask you how you measure PET. So simply the name of this, equation you have to remember. Okay, simply the name of the scientist you have to remember, Penman. Okay, Penman's equation is used for measuring potential evapotranspiration. I hope this thing is very, very clear to you. Now we'll discuss the second method. Okay, tell me, everything clear till here? Tell me if everything is clear till here. Then now we'll move on to the second method, which is Blaney-Criddle equation. This is Penman equation. Now we'll discuss Blaney-Criddle equation. This is the second method, okay, and the last also. This is second and the last method to measure potential evapotranspiration. Okay. So how we measure Blaney-Criddle? How we measure potential evapotranspiration using Blaney-Criddle equation? So see, in Blaney-Criddle equation, we have a simple equation which is given by ER. ER is none other than your potential evapotranspiration. I will also solve one question with the help of which everything will be very clear to you. So potential evapotranspiration is represented by ER here, is equal to 2.54 multiplied by K, okay, summation PHTF upon 100. And PHTF upon 100 means, see, this is percentage, so percentage thing you need to divide by 100. You all know percentage means percent, so that's why we have divided by 100 here. Or simply you can write summation PHTF, okay, or let me write here summation of PHTF by 100. Okay, now what is the meaning of all these terms that we have to understand? What is the meaning of all these terms that we need to understand here one by one? So obviously this first term ER is potential evapotranspiration, okay. This is simply potential evapotranspiration as given by Blaney-Criddle. These are two scientists, okay, these are two different scientists, Blaney and Criddle. Both of them work together. So this will give you potential evapotranspiration centimeter. See, one thing you have to understand, see, this will give you potential evapotranspiration in inches, okay, and you know 1 inch is equal to 2.54 centimeter. So this will give you potential evapotranspiration in inches. So if you want to convert inch into centimeter, you have to multiply it by 2.54 centimeter. Yes or no? So that's why you are seeing a factor of 2.54 here. Otherwise, if 2.54 is not written here, okay, if 2.54 is not written here, that is that will give you potential evapotranspiration inches, okay. Yes or no? Perfect, great. So this potential evapotranspiration thing is clear, 2.54 is clear. What is K? Now let me write down the meaning of all these terms here. So what is K? K is crop factor, okay. Let me write here, what is K? Sir, K is crop factor simply. Okay, what is the meaning of crop factor? See, the meaning of crop factor is, see, evapotranspiration of this crop, in which we are interested to find the potential. See, obviously we find potential evapotranspiration of a given crop, okay. So we are interested in finding evapotranspiration of a given crop. So the ETC means, let me write ET here. ET means evapotranspiration of this given crop with respect to a reference crop, okay. ET naught means reference evapotranspiration, okay. We have a reference crop whose evapotranspiration is set as standard, okay. Let us say this is crop X, which is standard crop. Let us say this is X, which is a standard crop, and it is consuming, let us say, 10 mm water. Now we are interested in finding potential evapotranspiration for crop Y. And its potential evapotranspiration is, let us say, 6 mm. So what is the ratio of evapotranspiration of crop Y with respect to evapotranspiration of reference crop, it is 0.6. So this is crop factor. Okay, this is crop factor, or simply you can say crop coefficient, which means when you will compare it to reference crop, its evapotranspiration is 0.6 times. Okay, yes or no? So ET naught is reference crop evapotranspiration. Okay, ET naught is reference crop transpiration. Okay, when you will compare it with reference crop, that is your ET naught. And ETC is what? ETC is evapotranspiration of your given crop. ETC is evapotranspiration of your given crop. So I hope this thing is very, very clear to you. So now we'll move ahead. So this is K. Now what is pH? pH is monthly percentage of annual daytime hours. Monthly percentage of annual daytime hours. Monthly percentage of annual daytime hours. See, what is the meaning of this? That's I will explain. This I will explain in the question itself. Monthly percentage of annual daytime hours. Okay, sir. This is also clear. Now TF is mean monthly temperature in Fahrenheit. TF is, see, obviously temperature is in generally degree Celsius. You all know temperature is generally represented in degree Celsius, but here I will write in degree Fahrenheit. That's why F is there in subscript. So mean monthly temperature in degree Fahrenheit. Okay. Now let us solve one question. Okay, let us solve one question with the help of which we will easily understand what is the meaning of K, what is the meaning of pH, what is the meaning of TF. Okay, so this we will understand with the help of a example. Okay, so Sarthak is saying reservoir planning and sediment control. Sorry, please. Okay. Okay, reservoir planning and sediment control. There is one chapter in case Subramanya. If you want, you can read it from there. Okay. Yes, don't worry. Okay, I will highlight on these topics which you are saying in the class itself. Okay, so we have one question here. You can see we have one question here. We have to solve it. Now. We have to solve it. Now, listen very carefully. How we will solve this question, how we will solve it, we have to understand here. So you can see in this question it is saying estimate the potential evapotranspiration of an area. Okay, we have an area. Let us say we have a field. Okay, we have a field of certain area. Let us say 100 hectare, 1000 hectare, whatever it is, no problem. Okay, whatever field area is there, you will multiply that field area with the potential evapotranspiration depth, and you will get the total volume of evapotranspiration. Yes or no? Okay, so we have 4 months: November, December, January and February, which means you have sown the crop in November month, but you have harvested in the month of February. So this crop is staying in the field. This crop is remaining in the field for 4 months: November, December, January, February. Okay, and the temperature you can also see in November the mean temperature in degree Celsius is 16.5. In December temperature is different. See, one thing you should appreciate, that in all the months we have different temperatures, that is for sure. So in every month evapotranspiration will also be different. Sir, you told me that potential evapotranspiration is different for different temperature. It is different when temperature is different. When sunshine is different, in that case it will also differ. So potential evapotranspiration is dependent on climatic conditions. If we have different temperature, in that case I will have different evapotranspiration. Okay, now what is the meaning of monthly percentage of annual daytime hours here? See, we have to understand this thing also. Okay, then we'll apply the formula. So listen very carefully. This monthly percentage of annual daytime hours is, can you tell me how many hours are there in entire year? You all know that in 1 year we have 365 days. You all know this thing. This is very simple. Okay, everyone knows this. If we want to find the total number of hours, in entire year, we are talking of entire year, then we have to multiply it by 24. Okay, if we'll multiply them, we will get it somewhere around Okay, let us assume it is coming as 10,000. Okay, obviously it is not equal to, but simply we are assuming it. Okay, just assume that we are getting it as 10,000 hours. Obviously you need to understand, you need to appreciate that in entire hours in this entire year, some will be daytime hours and some will be nighttime hours. Okay, some hours will be coming in day and some will be witnessing night. Okay, so some are daytime, some are daytime hours and some are nighttime hours. Obviously we are not interested in nighttime hours, sir. Why? Because sir, you have already told me that in night time no evapotranspiration will be there. In night time no evapotranspiration is there. Yes or no? Perfect, sir. So let us say out of this 10,000, 6,000 hours are daytime hours. Just assume 6,000 hours are daytime hours. Now out of this 6,000, we are only considering daytime hours. We are only interested in 6,000. We are not interested in 10,000. We are not taking all the hours of entire year. Okay. Now this 6,000 hours which are witnessing daytime, some daytime hours will be present in January, some will be present in February, like this. Okay, out of the 6,000, let us say 500 are present in let us say January, 500 are present in February, okay, 480 present in March, like this. But when you will sum up all these, when you will sum up the daytime hours of each and every month, you will get it equal to 6,000 only. Let us say in January we have 500 hours. So in January, monthly percentage of annual daytime hours in January is 500. 500 daytime hours are there in January. 500 daytime hours are there in January out of total 6,000 hours in entire year. Out of total 6,000 daytime hours in entire year, multiplied by 100, how much percentage will come? Okay, how much percentage you are getting? 50 upon 6, which means you are getting it somewhere around 8%. Okay, so this means this percentage is indicating that in January, sorry, in November, in December, January, February, in these months, in these corresponding months, how much is the percentage, how much is the total percentage of total annual daytime hours? If annual daytime hours is 6,000, that in entire year we have 6,000 day hours, then in January 7.19 is there, in November 7.19 is there, in December 7.15, in January 7.30%, in February 7.30. You will see that in May, June, July, when sun is at its peak, then you will say that percentage will increase. But when you will sum up all these percentages of entire year, when you will sum up the percentages of this entire year, you will see it is equal to 100. Okay, so this percentage thing, have you understood? Now you have understood what pH is. So pH is monthly percentage of annual daytime hours. How much percentage of daytime hours are present in November month? How much percentage of annual daytime hours are present in December month? Like this. Okay, so I hope this thing is clear to you. Wait a second, let me remove this thing. Okay, so this pH thing is clear to you. Now the second thing is, we have to convert this temperature into degree Fahrenheit. Okay, because sir, you have told us that we have to put the temperature in degree Fahrenheit. Okay, you have told us to, see, pH is clear. See, in this question K is also given to us. Okay, if you'll see, K is also given to us. Crop factor is 0.65 here. Okay, now sir, tell me how to convert temperature from degree Celsius to degree Fahrenheit. So one conversion factor is there. Okay, one conversion factor is there. What I will do, see, if you want to convert your temperature into degree Celsius, one simple formula is there. You can convert your temperature into degree Fahrenheit using this formula: 9 by 5 Tc plus 32. Okay, put the temperature in centigrade here. Okay, and convert it into Fahrenheit. Now I am telling you how to solve the question. With the help of that, you have to find the answer. Okay, so what you have to do, basically convert all these temperatures into degree Fahrenheit. Put 16.5 here, multiply this value plus 32, you will get temperature in Fahrenheit. Write all the temperatures in Fahrenheit here. Now multiply this pH by TF. See, this is TF and this column is pH. Multiply both of them. Okay, multiply both of them. You will get 4 values. Sum it up, sum those values, divide by 100, multiply by 0.65, which is K, multiply by 2.54, you will get potential evapotranspiration. Okay, so convert these temperatures, multiply them add them, divide by 100, multiply by K, multiply by 2.54 and get the value of ER. Okay, so I'm giving you 2 minutes time. Let me see who can solve potential evapotranspiration here. Okay, I'm giving you 1 or 2 minutes time. Convert all these temperatures into degree Fahrenheit and get the values of potential evapotranspiration here. Yes or no? Everyone, fast. Quickly solve it. So I hope you have solved it. Have you got the answer here? Have you got the answer here? So in this question, when you will convert all these temperatures from degree Celsius to degree Fahrenheit, okay, so it's simple. Let me solve one. So 9 by 5, when you will multiply it by 16.5 and when you will add 32, you will get this value somewhere around 60 degrees. Okay, you will get it around 60 degrees Celsius. So like this, you will convert all these temperatures into degree Fahrenheit. So let me write in the bracket here. In the bracket, this will be 60 degree Fahrenheit. Similarly, this value will be 55 degree Fahrenheit. I hope with the help of this formula, you are able to convert it. Then this 11 degree Celsius is 51 degree Fahrenheit. Okay, this 14.5 thing is 58 degree Fahrenheit. I hope you have converted it. Now we will make a column which is pH multiply by TF divided by 100. Okay, we will multiply this value by this. Multiply 60 into 7.19. multiply 60 into, wait a second, sorry, wait a second, this is wrong, this data is wrong here. Wait a second, let me solve it on calc. Wait a second. Yes, so for this question, converted how much you are getting, converted how much we are getting here. Wait a second. Hmm. Yes, so this will give you a value. Wait a second here. This is giving you how much degree Fahrenheit? So this will be giving you 61.7. Yes, now 61.7 degree Fahrenheit. This 13 thing, when you will convert, it will be 55.4 degree Fahrenheit. This will be 51.8 degree Fahrenheit, and this will be equal to 58.1 degree Fahrenheit. Okay, so now you will multiply pH by TF and divide by 100. See, this is pH, this is column for pH, and this is column for TF. Multiply them, divide by 100. So 7.19 multiply by 61.7 divided by 100, you will get it somewhere around 4.44. Okay, similarly you will multiply 7.15 by 55.4 divided by 100, you will get 3.96. You will get 3.96. Similarly, you will multiply 7.30 by 51.8 divided by 100, you will get it 3.78. And at last, when you will multiply 7.03 by 58.1 and divide by 100, you will get it as 4.08. Okay, so I hope this thing is clear to you. Now what you have to do, you have to sum up all these values. Okay, what you have to do, basically you have to sum these up. Okay, find the sum of these values. So the sum of these values will be summation PHTF upon 100. So summation PHTF upon 100 is, tell me how much you are getting here. How much you are getting here, sir? We are getting here, when you will sum it up, we will get it as 16.26. We will get it as 16.26. So we will apply this formula. Simply we will apply this formula. Okay, potential evapotranspiration is given by, potential evapotranspiration is given by 2.54 multiplied by K multiplied by summation PHTF upon 100. Okay, so simply put the values, 2.54 into K is crop factor, which is given as 0.65 here. This is given as 0.65. Summation PHTF upon 100 is 16.26. 16.26. So how much we are getting here? Multiply it. Tell me how much we are getting. Have you solved this thing? How much we are getting here? When you will multiply this, we are getting it as somewhere around 26. Okay, so this is 26.85 centimeter. This is 26.85 centimeter. So this is the potential evapotranspiration based on Blaney-Criddle equation. Okay, so with the help of Blaney-Criddle, we will solve potential evapotranspiration like this. So I hope this thing is very, very clear to you. See, crop factor is telling you that this crop which they are talking of is consuming 65% water, is consuming 65% evapotranspiration needs as that of reference crop. Okay, reference crop is consuming 100%, then your given crop is consuming only 65%. Okay, so this is implying here. Okay, so I hope this potential evapotranspiration thing is very, very clear to you. How you measure it, that is also done, and I think we'll discuss all the topics later. Okay, we'll discuss droughts and arid index in the next class. I hope it is clear to you. Yes, so let's solve one or two questions before ending our class. Okay, let's solve one or two questions. So let me see if you are able to answer this question. So in today's class we have discussed about evaporation, transpiration, evapotranspiration, how to measure actual evapotranspiration, how to measure potential evapotranspiration. Okay, I hope all these things are very clear to you. Now tell me the answer to this question. Can anyone guess the answer here? Can anyone guess the answer here? So this question has been asked in GATE examination once. Okay, they are simply asking you what is the ratio of actual evapotranspiration to potential evapotranspiration. Okay, ratio of actual evapotranspiration and potential evapotranspiration will be in the range of 0 to 0.4, 0.6 to 0.9, 0 to 1, 1 to 2. Tell me. Everyone kindly comment. Let me check if you are able to answer this question. So you are saying don't know. Okay. See, it's a simple question. Nothing tough is there. See, I told you that they are asking about ratio of actual evapotranspiration and potential. You all know that potential is higher. Generally, potential is higher, or you can say the maximum evapotranspiration at a given temperature and at a given condition of climatic factors. Okay. See, if climatic conditions and your temperature is fixed, then potential evapotranspiration, the maximum value is also fixed. Okay. I have already told you that this potential evapotranspiration thing, I have already told you today that this potential evapotranspiration thing depends on temperature, depends on climatic conditions. Okay. In every month, you will have different kind of potential evapotranspiration. So let us assume what I am saying here is yes. Potential evapotranspiration is maximum value. Sir, you are saying it absolutely correct that potential evapotranspiration depends on temperature, climatic conditions, everything, but it is the maximum value. Now, actual evapotranspiration, okay, sir, actual evapotranspiration is less than or equal to potential evapotranspiration. Okay, let us say the climatic conditions are optimized and you have provided sufficient moisture, then in that case, sir, actual evapotranspiration will be equal to potential evapotranspiration. Yes or no? But sometimes that can also happen. Sometimes I already told you that it can also become equal to zero when you have provided no water. If you are not irrigating your crops properly and you have left them dry for a long time, then in that case you will see that evapotranspiration is zero and all your plant leaves will start wilting. Yes or no? So actually evapotranspiration will vary from here to here. Now they are saying what will be the range of ratio of actual evapotranspiration to potential evapotranspiration. They are asking the ratio of these. Okay, so the ratio of this will be, yes Ajay, you are absolutely correct here. When actual evapotranspiration will be zero, this ratio will be zero. Yes or no? And when this actual evapotranspiration will be equal to PET, so PET upon PET will be 1. So then this ratio will be giving you maximum value and it will be equal to 1. So finally I can say that this ratio will be varying from 0 to 1. C option is perfectly correct here. Okay, great. So 0 to 1 is the answer, or simply you can say AET varies from 0 to PET. Okay. Now, this is the last question for the day. After this, we will end our class. So tell me the device with the help of which you measure evapotranspiration. Okay. I have told you today all the three devices already. Okay. So tell me this one. So tell me the device which is used to measure evaporation here. I am seeing all your comments here. Okay. Everyone kindly comment. See, these questions are generally framed in your examinations. Okay, they will ask what parameter is measured by which meter, or this meter measure which parameter. Such type of questions like match the columns are also there. Okay, so tell me the device which is used to measure evaporation is atmometer. I told you today. Okay, I will write answer to all of them. See, phytometer measures transpiration. Okay, sir, phytometer measures transpiration. Sir, hygrometer measures humidity. Okay, hygro word is related to humidity only. So hygrometer is measuring humidity. Now, atmometer measures evaporation. Atmometer measures evaporation. So I hope this thing is also clear to you. Infiltrometer is measuring infiltration. Okay, infiltration we'll discuss later in the upcoming classes, and that is from Monday only. From Monday we'll discuss what infiltration is. Okay, yes. C is the correct answer. So these are the different parameters which are measured by these meters. So I hope this thing is very clear to you. So I hope it is clear. Okay, so your PPT is also ready. So I hope you have enjoyed the class. So this is it. Finally, we will end her end here, and we'll catch up from next topic, which is drought. Okay, so in this class, basically in today's class, basically we have discussed all the methods, how to reduce evaporation. We have discussed evapotranspiration. What is consumptive use? Consumptive use is the amount of evapotranspiration, or you can say it is the total evaporation needs of plant, which helps in its growth. Potential evapotranspiration, actual evapotranspiration, we have discussed all these things. Okay, we have discussed lysimeter concept, we have discussed Penman's equation, we have discussed Bleeding equation. Okay, we have solved an example, we have solved some small questions. So I hope with the help of this you are able to understand all the concepts greatly. Okay, so we'll end our class here. If you have any doubt you can ask, otherwise we'll end our session today. Okay, then we'll catch up on Monday, and from Monday we'll start the remaining topics. Now in this chapter only 3 things are left, basically. Drought thing I will tell you. Okay, what is drought, what is aridity index, some theory part is there. Then at last we have to discuss about infiltration. Okay, see, infiltration is one of the most important topics of this chapter. Many a times questions have been framed in gate examination from infiltration, so we'll discuss that in the upcoming classes. Like what is Horton's equation, okay, how you discuss, how you calculate total infiltration, what is phi index, W index, all these things are which are very important, we'll discuss in the next class. Okay, so before ending, let me tell you, please keep practicing all your previous year questions simultaneously, because till now we have already covered uh, you can say sufficient topics. So introduction to hydrology part, precipitation, from these you can cover your previous year questions. Okay, both from gate, the questions which have been asked in gate examination and the questions which have been asked in your engineering services. Okay, so you can cover them from there, and also keep revising these notes. Okay, so thank you everyone, stay blessed, take care, we'll catch up on Monday. Okay, so take care.